Okay, and now I'm going to turn to our speaker, and it gives me great pleasure to introduce him. Jeff Duckett is Emeritus Professor of Botany at Queen Mary in the University of London, and he currently works as a Research Associate at the Natural History Museum. He's published over 250 papers on the biology and evolution of lower land plants, and he was the 2008 recipient of the Linnaean Medal for Botany. His current projects include the effects of climate change and air pollution on London's bryophytes. So now I'm going to hand you over to Jeff for what I'm sure will be a really interesting and enjoyable talk. Thank you, Jeff.
Thank you for that glowing introduction. Hope I can live up to it. What I chose to speak about today was sort of changes that I have seen in Hampstead Heath over half a century, since 1968. Just with the regret was that in 1968 I didn't take any pictures, because it was very different then from what it is now, as I'll try and explain. But what's happened over the last half century? We've had the Clean Air Acts, coupled with socio-economic changes like the switch from coal to natural gas. And when we were rained on by soot and sulfur dioxide before the Clean Air Acts, this stopped. Another change has been in this century increased nitrogen oxide deposition from vehicle exhausts. And then there is climate change, which is driven by atmospheric carbon dioxide. So what I've tried to do today is to give some varied things in this presentation and things that you might not know. So it's not moving, sorry. There we are. So I thought, first of all, we'd look back and put a temporal context. Kenwood is ancient woodland. That is to say, it's woodland that's over 400 years old. It comprises oak standards, and I'll show some pictures, and hornbeam coppice. The question is then, it's 400 years old, how long has it been there? Well, in actual fact, Kenwood has been there for 6,000 to 7,000 years, which is a bit remarkable. It was established from trees returning to Britain after the end of the last glaciation 12,000 years ago. If you remember, if you were driving on the North Circular 12,000 years ago, you were often stopped by snowdrifts, but that doesn't happen anymore. And the trees returned, and the last tree, a native tree to get into Britain before sea levels were cut us off, rising sea levels cut us off, was the hornbeam, otherwise known as the Brexit tree. I will not be mentioning Brexit again. There are two native oaks in Britain, the sessile oak, which has a base of the leaf comes down to a tapers, whereas the pedunculate oak has got sort of knuckles or shoulders at the base of the leaf. Then there's an introduced oak on the heath, the turkey oak. The two oaks hybridize, so you can never be certain whether you're dealing with a pure sessile oak or pure pedunculate or English oak. There's also been a change in the heath in that the turkey oaks have increased. So the easiest way to tell these oaks apart is by looking at their acorns. The pedunculate oak and the sessile oak have got smooth cups to their acorns, whereas the turkey oak has got nice hairy acorn cups. There's a further oak on the heath, and that is the holm oak, Quercus ilex. Just nice pictures of the turkey oak. These are the acorns with their hairy cups, and there's some on the ground, which I took on in Kenwood yesterday, actually. It was rather fun. Some of the turkey oaks on the heath are very large, very elegant, very attractive trees. But the turkey oak is reproducing quite fast, and a lot of the young oaks on the heath are turkey oaks. There are also hybrid oaks on the heath. This is a semi-evergreen hybrid oak, and I'm not quite sure which one it is. I need to work it out. It's a hybrid between Quercus ilex and something else. There's something else I'm not sure about. A word about the importance of ancient woodland, carbon capture. If you plant a sapling, it captures about 1 pound of carbon a year, whereas a mature tree captures 50 pounds of carbon a year. So you don't have to delve into higher mathematics to work out that if you cut a big tree down, you've got to plant an awful lot of new ones to replace the carbon capture. And with a bit of politics now, there was an insurance company. An insurance company wanted to cut down some trees in Queen's Wood, and as a result, there were objections because we felt that the most important thing you preserve in London's environment is ancient woodland. Whatever you do, you don't cut down ancient woodland. And you might have seen this sign. I mean, stop home insurers felling trees. And so far, we're keeping our fingers crossed. We might have succeeded with Queen's Wood. The oldest trees on Hampstead Heath are about 400 plus. They're old pollarded trees along old hedge lines. Oaks get a lot older than that. Particularly, this is a picture of the Druid oak at Burnham Beeches, which is about 800 years old. Actually, I don't think that oaks are the oldest trees on the heath. I think the coppice hornbeam, some of the hornbeam coppice is probably older. And it would be wonderful if we could do a survey of the hornbeam coppice. I'll come back to that in a minute. Oak tree shape. Oak trees that grow in the open have got widely spreading crowns, trunk and widely spreading crowns. So if you look at the shape of a tree, you can tell where it grew. So it's rather fun walking around the heath, just looking at the shape of oak trees and seeing what shape they are, because from the shape of the tree, you can actually piece together a lot of its history. So this is an oak tree growing out in the open. If, on the other hand, you look at oak trees growing in closed woodland, these are oak standards, are very good for building ships' masts, furniture, and the coppice. This is hornbeam coppice. These coppice trees are probably about 90 years old. Remarkable that oaks are well over 100, 150 years old. But if you look more carefully at the coppice, you see that some of them aren't just a single stem. A lot of them have got several stems. So these came from a coppice that was cut down before. If you look at this one here, you can see there are some 1, 2, 3, 4 here, and they're more widely spaced. And they probably had the same origin. So my guess is that this coppice could be older than the oak trees. The trouble is you can't count the rings because you cut down the original tree. What would be very interesting was to do molecular work and look to see how much difference there was in the DNA between this branch and this branch. That would give you a feel for just how old some of these old coppices were. It'd be rather fun to go around the heath and actually look at the diameter of the hornbeam coppice, see if we can find the biggest one. I don't know where it is. Just a word about other native British trees. There's one good thing if you're interested about trees, you don't have to be a superb taxonomist, because there are not a great number of native British trees. Ash, beech, birch, field maple, wild service tree, wild cherry, rowan, white beam, willows, midland hawthorn, yew, and buckthorns. Non-native trees, the horse chestnut, the sweet chestnut, false acacia, red oak, walnut, sycamore, Norway maple, and all the other conifers. All the pine trees on the heath are there by human endeavour or whatever, because the Scots pine is native to Scotland. No native pine trees in England. A word about the buckthorns, because this is quite a fun story, and in particular the alder buckthorn, because this relates to other things at the heath. This is the alder buckthorn, Frangular ulmus. If you walk on the heath and look for it, you can see it at this time of the year with these nice blackberries. The alder buckthorn is a quite important plant. It produces incredibly pure charcoal, good for barbecues. But it was used in the Second World War until they brought in electric fuses for shells. And a botanical friend of mine, Paul Richards, his war effort was going around the countryside looking for the alder buckthorn to make into fuses. It is also the host of the brimstone butterfly. I like butterflies, and I could actually give a talk on butterflies, but that's another story. But the brimstone butterfly is a fascinating butterfly, which unfortunately isn't threatened. You'll see why in a minute. The brimstone butterfly is a butterfly that is spreading north, and it's a superb example of an animal, sorry, that's spreading in relation to climate change. Hopefully you can see all those light blue dots around the periphery. Brimstone butterfly is a spreading species. There's quite a lot of it on the heath. A bit more of that in a moment. But what are the threats to the trees on the heath? Diseases. Ash dieback is probably the one that worries us most. A lot of saplings of ash are dying with dieback, but I haven't seen any mature ash yet. Well, there probably are some that are suffering. Other threats to forests are atavism, and I'll explain atavism in a minute, and competition. Competition from introduced trees like sycamore, Norway maple, and the Turkey oak. And these are increasing, and some thought ought to be given to how they might be outcompeting our native trees. And then another problem with trees is reproduction. I'll come on to that in a moment. Right, atavism. Kenwood, designed by Humphrey Repton in 1791. Now run by English Heritage, whose mandate is to restore and maintain the original landscape whilst maintaining biodiversity at the same time. This is a view, many of you will recognise this, is his view looking from the dairy in Kenwood. And in the middle of this view is a blue arrow, and below the blue arrow is this. This is a thicket of the purging buckthorn, now, which is the host of the brimstone butterfly. Unfortunately, this thicket of alder buckthorn wasn't there in the original landscape, and it's got to come out. Be interested to know your views on that, whether you think it ought to come out or not. Reproductions of trees. Acorns, most years. Beech is a very, very interesting tree. It might surprise you to know that the northern limit of Britain, of beech in Britain, is the Chilterns and the Cotswolds. Any beech north of the Chilterns and the Cotswolds, not there originally by man's activity. Beech does not produce seeds every year. There are so-called mast years where it produces a lot. But in order for beech to reproduce, it needs a whole suite of things to be right. If we have an early frost, it kills the flower primordia. Fortunately, in London, we haven't had many of these recently. Then the next problem is mild winters. Rodents like beech seeds. So if it's a mild winter, the rodents survive and eat them all. If there is a late frost, when the flowers are emerging, this also kills the flowers. So there are these interacting factors which influence when you're actually going to get new seeds. Beech cannot regenerate in its own shade. It's too shaded. And there are also leaf miners which reduce photosynthesis in the seedlings by about 20%. It doesn't make it. So reproduction in beech is absolutely fascinating. Something else I say, the wild service tree. There are 4 wild service trees on the heath. The problem with the wild service tree and reproduction, the berries are very palatable. I've wondered it might be an interesting conservation exercise when the wild service tree is shedding its berries, if we actually planted a few, so they couldn't be eaten by rodents. That would be quite interesting to see whether we could increase the regeneration of the wild service tree. 2020 wasn't a very good mast year for beech. These are some beech masts that have shed their seeds from this year. My wife said, do not doctor that photograph. You're putting a lot of them very close together. In fact, they were widely scattered. Previous year, last year, was a very good mast year for lots of old beech husks from last year. And if you look at regeneration of beech, this next image is from Burnham Beeches. Beech regeneration is very episodic. You don't get a continuum of seedlings from this year's to much older. Very episodic because of this these sort of mast years and the factors that affect mast. As far as I can gather, probably most of the beech trees on the heath are planted. unlike the oaks. But enough of trees for the moment. Let's look at something else now. Kenwood bog, probably the largest sphagnum bog in Middlesex and a big conservation priority. Liz has already mentioned this. Sphagnum was first recorded there in 1877. Sphagnum Kenwood bog is a valley bog, a valley with nutrient-poor water draining into it and more or less permanently waterlogged. Over the past few years, there have been some dry summers and it's dried out a bit. However, in the past, this wasn't the only bog on Hampstead Heath. The two valleys where we have ponds now almost certainly were much bigger valley bogs. We know this because if you go to the Natural History Museum, we find species growing from Hampstead Heath from the 17th century, which are now extinct. This is what a sphagnum bog looks like in all its glory. And sphagnum is a very, very important plant. 6% of all the world's carbon is locked up in sphagnum, living and dead. This is a pristine sphagnum bog in Tierra del Fuego. We get exactly the same species of sphagnum in Britain. So one of the joys of working at the Natural History Museum is that it has this wonderful herbarium of over 5 million bryophytes alone. This is the old look at Natural History Museum with the plastic dinosaur and the skating, which won't take place this year. And this is the new look at Natural History Museum with a genuine whale skeleton in the Hinsey Hall. So called because Hinsey gave a lot of money to the Natural History Museum. But you could ask me questions about that, but I'd rather not answer them. An extinction on Hampstead Heath is sundew. An insectivorous plant grows in bogs. If this was reintroduced and introduced onto Kenwood, it would almost certainly grow. However, I would caution against this because it could well get in of its own accord if we maintain that Kenwood properly. If it gets in of its own accord, by molecular analysis, we can find out where the seeds came from. It's not the same as artificial introduction, which on the whole, I'm against. But it's a lovely insectivorous plant. We'd love to have that. We'd love to see that coming back. The Kenwood bog. This is the Kenwood bog. And top priority this year was restoration of the bog. It's been growing out, getting overgrown, a lot of scrub around the periphery, and on the inside of the bog, a lot of brambles, which are growing over the sphagnum. This is an action photograph of the Heath Hands, socially distancing and doing sterling work, shifting the brambles. They have done an incredible job. Wonderful. This was a bramble thicket which you couldn't get through. They've cleared all the brambles, and having cleared all the brambles, encouraged the growth of the largest English moss, Polytrichum, gets up to about 1 metre in height. It's now about 0.5 metre in height on the Kenwood bog and will continue to grow on the sphagnum. It's beautiful stuff. There are 3-4 species on the Kenwood bog. They all look rather different. This one, green one here, these two are different colours. Before the encroachment of the bramble, the sphagnum used to reproduce and produce capsules in the summer. Over the last 2 years, it has not produced capsules. This is because of the overshading of the brambles and the dry summer. Now we've got rid of the brambles, we should get this back to reproducing with real vim and vigour. Right, enough of the bog. Now to London's air. Lockdown, lockdown. It was said that lockdown would produce cleaner air. And in fact, this is the case, as you'll see in a minute. There have been 9 full moons since lockdown, since March, October especially, and there are 2 of them, and no fewer than 6 of the 9 of the new moons have been visible. If you want to go and look outside, either now if you're fed up or at the end of this talk, there should be a very good 90% waxing, waning moon. So during lockdown, fantastic views of the city from Highgate, moons and sunrise 30 miles away. I'll show you some of these images. This is an example of clear air. This is why I wish I'd taken pictures in the 1960s. It would have been very difficult to take pictures like this of London in the 1960s. The moon has been fantastic this year. This is 11th of May, 12th of May. This is a waning moon. So this moon is fatter than this moon. And then you get the full moon rising, the rising of the strawberry moon on the 5th of June, and then the waning crescent. You didn't used to be able to see thin waning crescents like this in London because of pollution, but you can now. I think that's a fantastic sight. You could also see sunsets, and this is a sunset, 20th, sun rises the 20th, 21st of April, and one day after another, the sun never rises in the same place. This is the 20th of April, and you can see a bit of a pylon. On the 21st, the sun has risen in a different place. The sun has moved left or further east, because the days are getting longer, and the sun has moved from here to here in a day. And beautiful views of the rising sun, and another rising sun. This is the horizon here is 30 miles away, which is staggering. And you had views like this of London. It looks more like Tuscany than difficult to believe. That's looking towards Epping Forest in May. And one thing that is nice, it is to see Battersea Power Station not belching soot and sulfur dioxide. Right, as a result of sulfur dioxide, it wiped out epiphytic lichens and bryophytes, mosses and liverworts, or epiphytes growing on trees. In fact, London became a virtual lichen desert. There was just one species of lichen found as an epiphyte in London back in the 60s. Things have all changed. You don't have to look very far when you go on the heath to see a lot of lichens. There's one very obvious foliose lichen here, and others crustose lichens here. They're probably on that twig. There are probably at least a dozen different lichens. Another twig here. Very spectacular. You wouldn't have seen that in the past. These are increasing like mad, and you could go into the deepest countryside and the trees wouldn't look very different from those on Hampstead Heath. Right, now I'll share a seminal moment with you. Some of the key decisions of my life. You have to make decisions in life. And my key decisions were pheasant shooting, grouse shooting, fox hunting, playing golf, and lichen taxonomy. I decided to reject all of these alternatives. Well, it was not a good thing. And instead, I became a bryologist. And this is an example of bryologists. On the heath, this is below the bird bridge, looking at the parapet. There are some 700 of us, hunter-gatherers, sort of neo-hunter-gatherers. I decided to become one of those and specialise in mosses and liverworts. And the heath has a very special place here on the heath. In the year 2000, 99 species of mosses and liverworts were recorded from the heath. Today, 150 have been recorded. So why have they increased? Why? It's pretty dramatic. They've increased for different reasons. There were mass extinctions as a result of sulfur dioxide, acid rain, and bare, dirty bark. When the sulfur dioxide and the soot disappeared, the epiphytes came back, helped by the fact that London plane trees were sort of self-adapted to sooty climate in that the bark exfoliates, falls off. And some of you might have heard of or actually knew Ted Wallace, who was a famous London botanist, lived in the same road all his life in Sutton. And throughout his life, he documented a decline in bryophytes in London. I'm really sad that Ted didn't live a bit longer because things have changed. So as a result of the Clean Air Acts, by 2005, just about everything that had disappeared in the Industrial Revolution had returned to London. There were huge changes. Everything came back. And then came a second coming, if you like, nitrogen deposition. Now, I just put that in because hopefully you might have lost by the time I finished. This is an example of what clean air has done to bryophyte distributions. This is an epiphytic moss. In the 1960s, this was the distribution of this moss. There was one record in the London area and a lot of hollow circles. You can tell when you're getting old as a botanist, because when you get old, some of your records become hollow circles. If you look at a place where you've done recording and the circles are hollow, you are definitely aged. And this is Orthotricum lyalii today, and you can see it has spread like mad. It used to be on the Heath. First record on the Heath was 1992. Now it's everywhere, including trees along roadside. This is a tree in Pond Square, Highgate, and this is the moss. So that's clean air and done dramatic things. That's done dramatic things to mosses, also to liverworts. This is a leafy liverwort, which is rather attractive looking plant. And this is Frullania dilatata. This was in 1968. You can see it's missing from large swathes of industrial England. And now today, you can see it's all over the place. I could show you this very, very easily in London. It's all over the Heath now. The first record we ever had was, I think, in 1969 in London from Ruislip Woods. We're all jumping up and drowning with glee. And now it's very easy to find. So those are two examples of something, of plants that have changed because of clean air. There are others that have changed in their distributions because of climate change. And this is one of the best examples I know of an organism that's changed its distribution as a result of climate change. It's a diminutive liverwort. In the 1960s, if you wanted to see it, you had to go to Cornwall. This was its distribution in the 1960s. Which a pretty restricted southern distribution. This is its distribution today. And this is 2014. This is out of date. I could actually go now and fill in this map, and it's all over London. It was first found on the Heath 10 years ago, and there's more and more of this. So this is a species which is spreading as a result of climate change. Very dramatic. So not only is London's skyline changing, this is 2008 before the shard, 2019 with the shard. Staggering. The plants are also changing very, very dramatically. So by about 2005, everything that had disappeared as a result of the Industrial Revolution had returned. Since then, however, there's still been a massive increase in epiphytes on main roads. And that might be best summed up by the Bob Dylan song that the trees there are changing. This is a horrible map. This is a map of nitrogen dioxide concentrations in London. As you can see, nitrogen dioxide is higher in central London, and nitrogen dioxide picks out all the major roads around London. It's not a nice sight. And out here, this is Heath Row. I'd actually like to see the map of nitrogen dioxide for this year. I haven't been able to find one. It's not going to look like this. As a result of this, epiphytes have increased leaps and bounds on major roads in London and also on the Heath. This is a moss, which in 1992 was a bit thin on the ground in this area here. And now it has increased dramatically, this nice moss here. This is very much an urban moss that likes nitrogen. It's picked up, you can find it in South Wales, in Cardiff, loads of it in Cardiff, Swansea. It's also being picked up now in Liverpool and Manchester. There aren't many dots here because there aren't many people doing the recording. It's very much an urban moss that's increasing. Gives you an idea of how much epiphytes are increasing as a result of nitrogen. This is some of you might even recognize this wall and this tree. It's just outside Kenwood on Hampstead Lane. This green trunk, you'd never have seen this in about the year 2000. All this has happened since the year 2000. Recolonization by epiphytes. As a result, they like nitrogen fertilizer from car exhaust. Humans don't like it, but mosses do. So what about the future? Just to round things off, the problem with the future is there are no botanists left to do the recording or the experiments. How many professional botanists are there today in Britain able to identify bryophytes? The answer is none. This lack of botany isn't helped by fauna-centric florophobic media. These neologisms, I think, are particularly apposite. All the natural history programs are about animals. Without plants, the animals wouldn't be there. I just wish they'd get the balance right. So this is a very common moss. I'm showing this picture because it's very pretty. How many academics do you think employed in British universities could recognise this exceedingly common British moss growing all over London? It's a lovely plant. And the answer is 0. In 1982, I attended a conference of British professors of botany. There's some striking things about that. There's one here that looks like Charles Darwin. In fact, that's John Raven from Dundee University. You notice how they're all wearing jackets and ties. The other thing to notice is that there are only 2 women. Things have changed a bit. So there were 32 professors in that photograph. I took the photograph, 2 females in 1982. So there's much better gender balance between males and females in botany. But the 139 universities, 10 in London, there isn't a single person employed who can identify bryophytes. There are a few who could do higher plants, but then again, that's very low. There's a huge botanical problem, lack of botanists. Anyhow, I think that's a good time to stop. Okay, thank you.
Thanks, Jeff. That was a great talk, and you ranged over quite a lot of different areas, which was interesting. I particularly thought the kind of how you're showing the impact of those 3 different factors: the clean air, the climate change, and then the nitrogen deposition, having a massive impact on the bryophytes, the liverworts and the mosses in particular, in quite a short space of time. So even since 2000, that was very striking, and something I really hadn't realised that it was such a rapid change. We've got, I think, already quite a few questions coming through in the chat. So are we all right to go straight over to some questions now?
Yes.
Okay. So
how do we put those up?
Well, I hope is Anchor, are you around to start going have a look at some of the questions?
I am here, yes. Yes, oops, hello, I'm back.
Hiya.
Yeah, I've got a few questions for you, Jeff. So the first question is mast year a constant across a large geographical area, or is it more localized?
It varies, it depends. When you get into the limit of the distribution of a species, it's very episodic. So, I mean, it'd be an interesting thing to do. I mean, I've never ever done it. There are things the things you haven't done that you should have done are sort of regular recording. I mean, this isn't a good mast year. It's certainly not a good mast year in the Chilterns. I haven't actually looked properly at the beech trees on the heath, where some years you get loads of seeds. And then the following, some springs, you get an absolute carpet of beech seedlings. But you don't see that very often. But if you go more into the centre of distribution of beech in Europe, I think you could get mast every year. By the way, the northern limit of beech in Europe is the Chilterns. The southern limit is the top of Mount Etna in Sicily.
Anchor, I think you've muted yourself, Anchor, if you're going to ask another question.
I've muted myself. Okay, I should stop doing that. There was another question, which is a little bit different, where I think it was from Tommy, who said that you had stated that you were against the introduction of native plants. And so he wanted you to elaborate on that.
All right, that is you would not introduce native plants until you actually knew you'd done the molecular work, knew how closely they matched the things that were already there. Unfortunately, when it comes to Kenwood Bog, we have very poor documentation of the history of Kenwood Bog. But we do know through sort of whispers that at some stage, one of the gardeners at Kenwood dug some, well, got some sphagnum from somewhere else and put it on that bog. And that was very sad, because we know a lot about molecular work on sphagnum, but that ruined us actually being able to find out where the native sphagnum actually came from. So you really have to be very, very careful when you're going to do introductions about the genetic makeup of the plants you're looking at. I mean, it would be rather nice to have sundew growing there, but I wouldn't touch that unless I knew a lot about the molecular genetics of molecular biology of sundews. So I'm very aware of that.
And then we've got a question about, I think somebody got a little bit confused about atavism, and could you maybe explain a little bit more?
That's just being tongue-in-cheek, going back to ancestral tendencies. And I just gave you an example of a clump of trees, young clump of trees, which wasn't there in 1791, and the plan is to take it out. But it's a great place for the brimstone butterfly. So I was really hoping that when I looked it up, that the brimstone butterfly was going to be rare and endangered on the heath. So we'd leave the clump of trees there because I rather like it. But unfortunately not. So it just, so sometimes I think you have to be very careful about going back to answer to the past. You've got to be very careful what you do.
Absolutely. So there are a couple questions here also. With the species that have returned, have they been from new colonization, or were they lying dormant and then?
New colonization. I mean, the thing about mosses and lichens, they produce spores, so they get in by airborne spores or asexual propagules. No, they're all new arrivals.
And with the, you have the Coleogenia minutissima.
Yes.
Yes, this new one. Is this going to impact the kind of the native bryophytes that are?
No. Well, actually, that Coleogenia minutissima, if I tell you those little star-shaped things are less than 1 millimeter across, it's actually, in fact, it probably qualifies as the smallest British liverwort. I mean, what's one of the sort of fun things? If you know what it looks like, you can walk through a woodland and see a tree 6 feet away and say, that's what that colour is, which is kind of fun. I mean, if you really want to see that, just before lockdown, I did an excursion to Big Wood, and Big Wood is absolutely dripping with that plant. It's staggering. It was 10 years ago, there wasn't any there. No, there is one moss which is an invasive. It's a native of the mountains in southern Africa, in the Drakensberg and Mount Kenya, Mount Kilimanjaro. That's another story, but it's not a problem on the heath. It's a problem in some other habitats, but not the heath. It does grow on the heath, but it's not. If I was going to give another thought, I could give another talk and talk about things that I haven't talked about this time at all. That would be, and the introduction would be, introduce things would be fun.
Okay, I'm going to let David Bevan come in now, if that's okay, and he's going to ask a question in person. David, do you want to unmute yourself? Click it. Yeah, that's it.
Yeah, you're all right now, David.
Jeff, I just wanted to challenge is the wrong word, but you mentioned that alder buckthorn was a problem in some places. But I think you meant buckthorn itself. Alder buckthorn is native on the heath.
Yes, but that clump of alder buckthorn, it destroys the sort of Repton vista.
Yes, lots of it's been planted. I agree, yes. But it does occur naturally as well.
Oh, it does, yes. Oh, in actual fact, with the Kenwood bog clearance, one of the things I suggested to the Heath Hands was actually, if you see alder buckthorn, don't leave that there.
Right.
Get rid of everything else, but leave the alder buckthorn.
Both those plants, of course, are food plants for the brimstone. Buckthorn itself, I think, was introduced originally and doesn't occur naturally.
Yes, I think
But
that's
all the
good.
buckthorn does.
Yes, if you look at the
The-
original distribution of alder buckthorn, it's a really good sort of picks out the chalk almost. Picks out chalk and
Yes.
limestone if you see a chalk
Absolutely,
and
that's
limestone
right.
distribution.
Yes. But there's
Thanks.
not much chalk on the heath.
No, there isn't. There are wet bits.
Thank
Thanks,
you.
very
Thank
good.
you.
And can we go back to the chat now? Because I think there was a few other.
There are a few others. There's, been a few comments about the decline of studying of botany. So people are kind of wondering, is it because there are lack of courses at university level, and what we could do perhaps through natural history? I mean, I note that Kieran has put down that the FSC is offering courses very soon. Yay. But what else can be done, and what is causing the decline of botanists at universities?
If you really want the cynical answer, it's money.
Yeah.
Because botany is perceived as a subject where you don't get many bums on seats and there aren't many jobs. The interesting thing is there are far more jobs in botany than there are in zoology. We are short of botanical consultants. We are short of botanical expertise. All right, my interests are pretty esoteric, but I do practical stuff as well. Very, very much practical, applied botanical work, starting with liverworts. Another problem is teaching. A lot of teachers didn't like botany and gave minimal attention to it. It's very poorly taught in the A-level syllabus, in that a lot of it's taught just from the textbook. If you're doing biology, I'm a great believer that biology should be hands-on. You should actually be handling animals and plants. And I don't like the idea of just learning things by looking in textbooks. You learn an awful lot more by handling things. And it's interesting, the spin-off of this is there's very little microscopy taught in A-level as well, which is a shame because looking down a microscope adds another dimension. I used to teach the first year, first biology undergraduate class at Queen Mary, and it was use of a microscope. And it was fascinating over the years how less and less people knew how to use a microscope. It was like putting somebody in a car who'd never seen a car before. And I always had a lot of people in tears because they just had no idea what the controls were or what you did. So a combination of factors. I think it's very sad. I mean, I'm not 100% champion of Attenborough because I think his programs are too animal centered. I think there's an awful lot of interesting plant stuff which you could do and isn't done, and that would help.
I have to second you on the microscope work. I do plant cells myself. And my daughter, who's now 11, is always on my microscope.
Oh,
And I think
fantastic.
it's really, really good for children to learn about the microscopic world as well as the macroscopic. So,
Oh, yes.
Spot on with those comments. I absolutely agree. Completely different question, going back, to the macro. There was a question from Julia Solarski about why the brambles encroaching on the bogs, and if there's any way to prevent the encroachment without human intervention, or do we just need to keep going back and chopping it back?
Okay, one of the reasons they're encroaching is because there have been some rather dry spells. If the bog was completely waterlogged, the brambles won't grow. So that's the basic problem. I mean, probably as a result of the dry summers. I wouldn't say climate change, just a series of dry summers. But if you cutting back the brambles, some of it will come back again. But you really have set it back, and think it'll be really interesting to see how much better the sphagnum looks next year. I mean, it's been happening for a few years, but I say what it needed was a sort of slash and, I wouldn't say slash and burn, certainly a slash approach, which they did really fantastically. And we were also very lucky in that there was a period when it was very dry. You really can make a mess of a bog if you trample on it when it's wet. If it's dry, it's fairly bomb-proof. You can be much more, you can walk about on it a lot more without doing any damage. But it's wonderful that they managed to do all that with absolutely minimum damage. And the next thing to do, though, is I need to go looking for sex on the bog, because it's this time of the year that the sphagnum produces its sex organs. And so you can actually see the male plants. That'll be rather fun.
Can I just ask something about the wild service tree?
Yes.
And the possibility you talked about the possibility of maybe kind of propagating that using the berry. Is that something that has been tried elsewhere and been successful?
I've only ever been to one place that I've ever seen a lot of wild service tree seedlings. They were growing on a slope, on a steep slope, which was unstable, and the soil was falling down. When the soil was washed down, it buried the seeds, and you had a lot of seedlings. So it just struck me of, with a bit of a nudge here and there, that just planting some seeds would be really good, because it is annoying. You just don't see seedlings, and I think the main reason is because they get eaten. And it wouldn't be difficult.
It certainly sounds.
It would be lovely to do that. It would be lovely to get a lot more wild service trees.
Yeah, no, it certainly seems something that's worth trying. Thank you. I think have we got maybe time for one more question, Anka?
Yeah, I mean, there's one other question going back to the hornbeam and the dating of the hornbeam. Yes. How can you tell how old they are? Because you're saying that they could be up to 1,000 years old.
Oh yes.
So
I know one near Gatwick, and it's about the ring is about 10 meters across. That is an old tree. But I've always wanted somebody to do some molecular work, and you could age them by doing that. Again, you find out whether I was talking rubbish or not, or whether they actually did come from the same tree. But if you go around, this is another advantage of doing field work. You just wander through the woods and look at the coppice stools. You think, crumbs, this is an old one. This has been around for a long time. I think almost certainly they're older than the oaks. Somebody might like to disagree with me. We'll go out on the heath and argue about it if that's the case.
It'd be interesting to do a survey of them.
I think it would be an absolutely fascinating thing to do. I couldn't agree more. I sort of just going up and down and saying yes. And actually, if you got a GPS, you could actually mark them.
Yeah, so is that something you might be bearing in mind for the future, possibly?
It is. It would. Yes, I need a molecular collaborator, or we need a person who can do some DNA analysis, which isn't that expensive these days, but it would be rather fun.
Yeah, so so thank you very much, Jeff, and also thank you for everybody who's kind of contributing to all the fantastic work that's going on Hampstead Heath. It's been really nice to have a sense of, first of all, what the section has been working on. The contribution of the Heath Hands is obviously, made a big difference as well. And then Jeff, it's been really nice to kind of put that in a context, and particularly in a historical context. So I think everybody's really had a very enjoyable evening exploring all those different ideas. I want to just flag up before we finish a couple of things that we've got coming up next. So first of all, obviously you all have to